Hello students, this is Teacher Beth and welcome to my class. For today's lesson, our topic is about geometric sequence. At the end of the lesson, we should be able to attain the following objectives. First, we have to be able to define and illustrate geometric sequence. Second, to differentiate geometric sequence from an arithmetic sequence. And third, finding the common ratio, geometric means, and the nth term of a geometric sequence. To start our lesson, let us first define and illustrate geometric sequence. So what is a geometric sequence? Geometric sequence is a set of terms in which each term after the first is obtained by multiplying the preceding term by the same fixed number called the common ratio. It is commonly represented by small letter r. We have here 1, 2, 4, 8, and 16. It is an example of a geometric sequence. By observing, we can see that 2 is multiplied to any term to get the next term. Therefore, we can say that in this sequence, the common ratio r is equal to 2. The common ratio may be an integer or fraction. It can be negative or positive. It can be found by dividing any term by that term that precedes it. Let's take the given example. We have 1, 2, 4, 8, and 16. So let's solve for the common ratio or r. So 2 divided by 1 is equal to 2. 4 divided by 2 is equal to 2. 8 divided by 4 is equal to 2. And 16 divided by 8 is equal to 2. So we have proved that the common ratio of the given sequence is 2. So r is equal to 2. Now, let us try to determine the next two terms of the sequence. So to get the next terms, we have to multiply the terms by 2, our common ratio. The first term of the sequence is 1. So 1 multiplied by 2 is equal to 2. 2 multiplied by 2 is equal to 4. 4 multiplied by 2 is equal to 8. 8 times 2 is equal to 16. So it follows that 16 multiplied by 2 is equal to 32, and 32 times 2 is equal to 64. Therefore, the next two terms in the geometric sequence 1, 2, 4, 8, and 16 are 32 and 64. Let's differentiate geometric sequence from an arithmetic sequence. I have here a table that shows the difference between a geometric sequence and an arithmetic sequence. So let's start. The next term in an arithmetic sequence is obtained by adding a constant number. So the operation in getting the next term is addition. While in a geometric sequence, the next term is obtained by multiplying a constant number. So the operation for getting the next term is multiplication. Next, in an arithmetic sequence, the constant number is called the common difference or d. While in a geometric sequence, the constant number is called the common ratio or r. In an arithmetic sequence, to get the common difference, you have to subtract any term by the previous term or the term that precedes it. While in a geometric sequence, to get the common ratio, you have to divide the term by the previous term or the term that precedes it. So let's have an example. 3, 8, 13, 18, and 23. Is this an example of a geometric sequence? Let's solve. 3, 8, 13, 18, and 23. So let's solve for r by dividing. 8 divided by 3 is equal to 8 over 3. 13 divided by 8 is equal to 13 over 8. 18 divided by 13 is equal to 18 over 13. 23 divided by 18 is equal to 23 over 18. So you can see that we have no common ratio. However, we have a common difference, and the common difference is 5. Therefore, the given sequence is not a geometric sequence, but an arithmetic sequence. Another example. In the sequence negative 20, 10, negative 5, and 5 halves, prove that it is a geometric sequence. So 10 divided by negative 20 is negative 1 half. Negative 5 divided by 10 is equal to negative 1 half. 5 halves divided by negative 5 is equal to negative 1 half. So there is a common ratio, and that common ratio is equal to negative 1 half. Hence, we prove that the given sequence negative 20, 10, negative 5, and 5 halves is a geometric sequence. Now it's your turn. Try to solve this one. 6, 12, 24, and 48. Is it a geometric sequence or not? I will be giving you 30 seconds to determine if it is a geometric sequence. So if it is a geometric sequence, you have to find the common ratio, the value of r. Start. Time's up. What's your answer? That is correct. Geometric sequence. Very good. By solving for the common ratio, we have 12 divided by 6 is equal to 2. 24 divided by 12 is equal to 2. 48 divided by 24 is equal to 2. So the common ratio is 2. So it is a geometric sequence. The nth term of a geometric sequence can be obtained by the formula a sub n is equal to a sub 1 multiplied by r raised to n minus 1, where a sub n is the nth term or the last term of a sequence, a sub 1 is the first term, r is the common ratio, and n is the number of terms in a sequence. So let's have an example. Find the 11th term of the geometric sequence negative 40, 20, negative 10, and 5. So to get the 11th term, we will be using the formula a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So let us identify first the given. We have a sub n. Our a sub n would be a sub 11 because we are looking for the 11th term. A sub 1, so our first term is negative 40. N, so our n is 11 terms since we are looking for the 11th term. And our r is equal to negative 1 half. So substituting the value, we have a sub 11 is equal to negative 40 multiplied by negative 1 half raised to 11 minus 1. So a sub 11 is equal to negative 40 multiplied by 11 minus 1 would be 10. So negative 1 half raised to 10. Next, a sub 11 is equal to negative 40 multiplied by negative 1 half raised to 10 would be 1 over 1024. So a sub 11 is equal to negative 40 times 1 over 1024 would be negative 5 over 128. So the 11th term in the sequence is negative 5 over 128. Another example. Solve for the 6th term of a sequence with a sub 1 or first term which is 4, and r, or the common ratio, which is 3. So substituting in the formula, a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So a sub 6 is equal to 4 multiplied by 3 raised to 6 minus 1. So 6 minus 1 is 5. That would be a sub 6 is equal to 4 multiplied by 3 raised to 5. And 3 raised to 5 is equal to 243. So that would be a sub 6 is equal to 4 multiplied by 243. So a sub 6 is equal to 972. So the sixth term, or a sub 6, is 972. Geometric means. Geometric means are terms between any two given terms of a geometric sequence. So in the sequence negative 40, 20, negative 10, 5, negative 5 halves, the geometric means between negative 40 and negative 5 halves are 20, negative 10, and 5. So let's have an example. Insert two geometric means between 8 and 1. So let's have our given. So a sub 4, or the last term, is 1. A sub 1, or the first term, is 8. M, or the number of terms, is 4. And R is unknown. So substituting in the formula, we have a sub 4 is equal to a sub 1 multiplied by r raised to n minus 1. So 1 is equal to 8 multiplied by r raised to 4 minus 1. So 4 minus 1, that would be 1 is equal to 8 multiplied by r raised to 3. So solving for r cubed, divide both side by 8. So we have r cubed is equal to 1/8. So getting the cube root of both equations, so we have r is equal to 1/2. So the first term is 8. So 8 multiplied by the common ratio, which is 1/2. So 8 multiplied by 1/2 is 4. So the next term is 4. Then 4 multiplied by 1/2 is 2. So the next term is 2. So the geometric means between 8 and 1 is 4 and 2. A geometric mean of two numbers is specifically called the mean proportional, and it is obtained by getting the square root of their product. Say for example, we have find the mean proportional of 3 and 12. So to get the value, we have the square root of 3 multiplied by 12. So the square root of 36. So the mean proportional of 3 and 12 is positive and negative 6. How about the mean proportional of negative 2 and negative 12? So the mean proportional is equal to square root of negative 2 multiplied by negative 12. So negative 2 multiplied by negative 12 is equal to 24. So square root of 24, so since it is not a perfect square, we have to look for a number that is a perfect square. That is a factor of 24. So that would be 4 multiplied by 6. So square root of 4 is 2. And 6 is not a perfect square. So the mean proportional of negative 2 and negative 12 is positive and negative 2 square root of 6. Okay, let's have some practice problems. Find the common ratio and the next three terms of the sequence 1 over 2,500, negative 1 over 500, 1 over 100, and negative 1 over 20. So to get the common ratio, we have to divide any term by the term that precedes it. So negative 1 over 500 divided by 1 over 2,500 is negative 5. 1 over 100 divided by negative 1 over 500 is negative 5. Negative 1 over 20 divided by 1 over 100 is equal to negative 5. So the common difference is negative 5. So r is equal to negative 5. To get the next three terms, we have to multiply the last term by the common ratio, which is negative 5. So the last term is negative 1 over 20 multiplied by negative 5, that would be 1/4. So 1/4 multiplied by negative 5 is equal to negative 5 over 4. Negative 5 over 4 multiplied by negative 5 is equal to 25 over 4. So the next three terms in the sequence 1 over 2,500, negative 1 over 500, 1 over 100, and negative 1 over 20 are 1/4, negative 5 over 4, and 25 over 4. Another example. Find the common ratio of the sequence 9, 3, 1, and 1/3. To solve, we have to divide the terms. So 3 divided by 9 is equal to 1/3. 1 divided by 3 is equal to 1/3. 1/3 divided by 1 is equal to 1/3. So the common ratio is 1/3. Next example, we have solve for the fifth term on the sequence 3, 6, and 12. Let's solve first for the common ratio. So we have to divide the previous term. 6 divided by 3, so that would be 2. 12 divided by 6, that would be 2. So r is equal to 2. Substituting in the formula, we have a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So a sub 5 is equal to 3 multiplied by 2 raised to 5 minus 1. So 5 minus 1 would be 4. So 3 multiplied by 2 raised to 4. 2 raised to 4 is equal to 16. So that would be a sub 5 is equal to 3 multiplied by 16. So the fifth term in the sequence is 48. Let's have a recap on our discussion. Geometric sequence is a sequence with a common ratio. The next term is obtained by multiplying the fixed number or the common ratio. Geometric mean is a term between any two given terms, and if it is only two given terms, their geometric mean is called mean proportional. The general form of a geometric sequence is a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So that is the end of our lesson for today. Hope you have learned a lot and had fun. Till our next discussion, goodbye. Stay safe, everyone.